Hello, my name is Stuart Russell. I'm a professor of computer science working at the University of California, Berkeley in artificial intelligence. I was in Berkeley that day teaching my undergraduate class on AI. I heard about the wall later that day, and by coincidence, I had a visa already to visit East Germany as a guest of Humboldt University. So a few weeks later, I was in East Berlin at the end of November in 1989. I got to eat East German food. I got to drive in a Trabi that broke down. I visited West Berlin with my hosts, and I brought home a piece of the wall. I always wanted to be a scientist, so that part came true. Specifically, I wanted to be a theoretical particle physicist, perhaps because of the excitement about quark theory when I was a child. My undergraduate degree at Oxford was in physics, but by then I had also developed an interest in AI. So I had to choose, and AI won, or lost, depending on how you see it. But life as an AI researcher has turned out to be wonderfully interesting and exciting, so I feel extremely lucky. I am aiming to replace the standard model of AI with a new model that has better outcomes for us. The standard model of AI, as well as control theory, operations research, statistics, economics, assumes that the objective to be achieved is fixed and known. So we build machines that find the best way to achieve a specified objective. This is fine until you realize that it's not possible to specify objectives completely and correctly in the real world, and that powerful AI systems pursuing the wrong objective present a very serious risk to humanity. In fact, the smarter the machine, the worse the potential outcomes. So I'm trying to fix that. I proposed a new mathematical model for AI under which machines are provably beneficial to humans. Human preferences about the future are part of the formal problem that the machine is designed to solve. But those preferences are assumed to be unknown by the machine. So when it starts from a position of uncertainty about true human preferences, the machine automatically defers to human requests. It asks for permission, and most importantly, it allows itself to be switched off. In this model, the smarter the machine, the more it can learn about our preferences, and the better it can satisfy them. So the better the outcomes will be for humanity. I hope that this new model for AI will allow us to benefit from machines of unlimited intelligence without ever losing control over them. Other than too many cups of tea, there are two major open questions I'm worried about. The first is the plasticity of human preferences. So if an AI system is designed to do what humans want, what's to stop it from changing what we want to make it easier to achieve? The second is a more profound cultural question. If we're able to hand over the operations of our civilization to intelligent machines, do we lose our incentive to learn and grow as a species? Do we become irreversibly enfeebled, like passengers on a cruise ship that goes on forever? My two older children, Gordon and Lucy, have attended talks that I've given in Boston and Budapest. So they're aware of some of the pessimistic predictions about our future with AI, and they're cautiously optimistic that not all is lost, as am I.